Shri Gurubhyo Namaha children. Welcome to our online teaching academy Ekalaiva. Exercise 7.4 fourth question. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? You have to select a team of 3 boys and 3 girls from 5 boys and 4 girls. So, how many boys are there totally? Number of boys is equal to 5. And how many girls are there? 4 girls. So, from 5 boys and 4 girls, we have to select a team of 3 boys and 3 girls. So, the required number of ways of selecting 3 boys and 3 girls from 5 boys and 4 girls is 3 boys we are going to select from 5 boys. So, it is 5C3 into, and 3 girls we are going to select from 4 boys. So, from 4 girls, sorry. So, 4C3. So, here what formula we have to use? NCR. What is NCR? N factorial by R factorial into N minus R factorial. So, 5C3 can be written as 5 factorial by 3 factorial into 5 minus 3 factorial into, what is 4C3? 4 factorial by 3 factorial into 4 minus 3 factorial. 5 factorial can be written as 5 into 4 into 3 factorial by 3 factorial. What is 5 minus 3? 2 factorial. What is 2 factorial? 2 into 4 factorial can be written as 4 into 3 factorial by 3 factorial. And 4 minus 3 is nothing but 1 factorial value is 1. So, this 3 factorial and this 3 factorial gets cancelled. These 2 gets cancelled. 2 1s are, 2 2s are. So, what is in the numerator? 5 2s are 10, 10 4s are 40. So, how many ways we can select 3 boys and 3 girls from 5 boys and 4 girls? 40 ways. Is it clear, children? Let us see the next question. Fifth one. Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. So, how many balls we have to select? 9 balls from 6 red balls, 5 white balls and 5 blue balls. If each selection, there is a condition, if each selection consists of 3 balls of each color. Out of the 9 balls, 3 balls should be in different colors. Okay, so how many balls has to be selected? 9 balls. So, total number of balls to be selected. Total number of balls to be selected is 9 balls. Okay, and how many white balls are there? How many red balls are there? 6. How many white balls are there? 5. How many blue balls are there? 5. Now they have given a condition. What condition? If each selection consists of 3 balls of each color, which means we have to select 3 red balls, 3 white balls and 3 blue balls to get the total number of balls to be 9. So, the required number of ways of selecting 9 balls from the given set of balls. So, we have to select 3 red balls from 6 red balls. So, 6C3 into, again we have to select 3 white balls from 5 white balls. So, 5C3 into, and we have to select 3 blue balls from 5 blue balls. So, again 5C3. So, how do you write 6C3 using NCR formula? 6 factorial by 3 factorial into 6 minus 3 factorial, because you know what is NCR. NCR is equal to N factorial by R factorial into N minus R factorial. So, into, what is 5C3? 5 factorial by 3 factorial into 5 minus 3 factorial into 5 factorial by 3 factorial into 5 minus 3 factorial. So, how do you write 6 factorial? 6 into 5 into 4 into 3 factorial by 3 factorial, and this is 6 minus 3 factorial is value is 3 into 2 into 1. So, into 5 factorial I can write as 5 into 4 into 3 factorial by 3 factorial into what is 5 minus 3, 2 factorial value is 2 into 5 factorial again can be written as 5 into 4 into 3 factorial by 3 factorial, again 5 minus 3, 2 factorial is nothing but 2. So, this 3 factorials gets cancelled, these 2 gets cancelled, these 2 get cancelled, 3 ones are 3 twos are 2 gets cancelled, 2 ones are 2 twos are 2 ones are 2 twos are. So, what do you have here? 5 fours are 20 into 5 twos are 10 into 5 twos are 10. So, what is 20 into 10 into 10? 2000. So, how many ways we can select 9 balls from 6 red balls, 5 white balls and 5 blue balls? In such a way, we have selected 3 balls from each color, which means that 9 balls consist of 3 red balls, 3 white balls and 3 blue balls. So, we have selected in such a way 6C3, that is 3 red balls from 6 red balls, 3 white balls from 5 white balls and 3 blue balls from 5 blue balls. So, the selection has been made in such a way 6C3 into 5C3 into 5C3. When we do the value of that, you get the number of ways is 2000. So, how many ways we can select those values? 2000 ways. So, how many ways we select that? 2000 ways we selected it. 2000 ways of selecting those 9 balls. Is it clear, children? Now, let us move on to the 6th question. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly 1 ace in each combination. Determine the number of 5 card combination. That means we have to choose 5 cards out of a deck of 52 cards if there is exactly 1 ace in each combination. That is, we have to select 5 card combination, a combination of 5 cards from 52 cards. In that there should be 1 ace exactly. There should be exactly 1 ace. So, how many cards are there totally? 52 cards. How many cards are there totally? 52 cards. In that, how many aces are there? You know, the deck of 52 cards will have 4 aces. One from spade, one from club, one from heart and another from diamond. So, total number of cards is 52. In that, number of aces is 4. So, balance number of cards, that is without ace, how many will be there? 52 minus 4, 48 cards. Why I find this balance number of cards? Because I have to select 1 ace from this 4 card and the balance 4 cards from this 48 cards. What is the number of cards selection? I have to select number of cards selected. Number of cards to be selected is 5 cards. Number of cards to be selected is 5 cards. In that, there should be 1 ace. So, that 1 ace can be selected from the 4 aces and the balance 4 cards, that is 1 card will be ace, the balance 4 cards should be selected from 48 cards. So, only I found the balance number of cards. Balance number of cards. Balance number of cards. Okay, so total number of cards is 52. In that, number of aces is 4. So, the balance number of cards is 52 minus 4, 48. And how many cards are we going to select? 5 cards. In that, there should be exactly 1 ace. So, we have to choose 1 ace from this 4 cards and the balance 4 cards from this 48 cards. So, the required number of ways. The required number of ways of selecting these 5 cards will be 1 ace we have to select from this 4 cards. So, 4 C1, 1 ace from this 4 cards into the balance 4 cards from this 48. So, 48 C4. So, how to write 4 C1? Using the formula. What formula? NCR is equal to n factorial by r factorial into n minus r factorial. n minus r factorial. So, how do you write 4c1? 4 factorial by 1 factorial into 4 minus 1 factorial into 48 factorial by 4 factorial into 48 minus 4 factorial. So, it is 4 factorial can be written as 4 into 3 factorial by 1 factorial value is 1 and 4 minus 1 is 3 factorial into 48 factorial can be written as 48 into 47 into 46 into 45 into 44 factorial. Why I write 44 factorial? Because in the denominator also I am getting 44 factorial. How do you write 4 factorial? 4 into 3 into 2 into 1 into 44 factorial. So, these two gets cancelled, these two gets cancelled, this 4 and this 4 can be cancelled, and 3 2s are 6, 6 8s are 48. So, when I multiply 47 into 46 into 45 into 8, so 47 into 46, so I get 282 here and 188, 4, 24, 282. So, I get 2162 into 45, 3, 8, 1, 0, 8, 24, 2, 6, 8, 2, 0, 9, 12, 7, 9, 97,290 into 1 more 8. So, 97,290 into 8 is 0, 2, 7, 16, 32, 3, 56, 7, 16, 20, 0, 9 is a 7, 16, 23, 2, 7 8 is a 56, 58, 5, 72, 77. So, I get 7,78,320. So, how many ways I can select 5 cards from the 52 cards with 1 ace in it? 7,78,320 ways. So, how did I select that? Out of the 52 cards, how many aces are there? 4 aces and balance number of cards, that is besides ace, how many cards will be there? 48 cards. How many cards I have to select? 5. In that, there should be exactly 1 ace. So, 1 ace will be selected from these 4 cards and the balance 4 cards will be selected from this 48 cards. So, the required number of ace is 4c1 into 48c4, that is 1 ace from this 4 ace and the balance 4 cards from this 48 cards. So, when I simplify that, I get the value as 7,78,320. So, we can select the 5 cards in 7,78,320 ways. Is it clear, children? To receive our online lessons, please click the subscribe button to get the latest updates. Thank you.